define greeting, empty parentheses, because you don't have to pass anything in. It doesn't take any arguments. It doesn't operate on anything. It just says, I'm going to give back the value string hello. Okay? Now, if I say something is assigned greeting and print something, it prints hello. So what did I just do? I told Python I wanted to find a new way to do things, a new verb. It's called greeting. Okay? I'm not expecting the caller to give me anything. Nothing gets passed in. It doesn't operate on any values, but it returns the string hello. That's what it gives back. No input, one output, the string hello. I can then call it just like I would the function len or the function square root or any other function that's built into Python. I just use the name of the function and then some parentheses saying, okay, now it's time to go call it. It goes and it gives me back the hello, which I've assigned to the variable something, and I can then print out that variable. This is no different in principle than saying something like number equals len of the string hello. Here, the function len is built into Python. I pass it in the string hello. I expect it to give me back the length. I gave you something, you gave me something back. Everybody okay with this? Okay. I could even shorten this a bit, of course, by just printing len of hello like that. I don't have to assign it to a variable and then print the variable. I can just catch the value that this is returning. I passed in the string hello. It said 5, and I just print that out. Okay. Similarly, I could just print greeting if I put in the space. It gives me back the string hello. I print that out. Okay. So now let's do something a little more sophisticated. There's my list of values, 1, 3, 5, 7. Okay, define a function called sum. Okay. It takes some numbers as an input. Okay. Total equals 0. For n in numbers, total plus equals whatever that number is, return total. Let's have a look at what I just did. That's the function I'm creating. I'm defining that. I'm telling Python, whoever calls this has to give it something. One thing. And locally we'll call that thing numbers. I don't care what it's called in the outside world. Inside, it's called numbers. It's like when I show up at the tax office in Toronto. Right? They give me a ticket. They say, you are number 71 today. I go, but I'm not a number. I'm a name. I'm Greg Wilson. They go, no. As long as you're inside this office, you are candidate number 71. Have a nice day. So, locally, whatever we're given is going to be called numbers. I've got a variable called total. It's inside the function. That only exists as long as we're running the function. Once the function's over, that disappears. And then I loop over the values in numbers. That's just a for loop. Add each number into total in turn, and then I return that to the caller. So, let me show you values again, and then print total of values. Print sum of values. Right, function's called sum. 1 plus 3 plus 5 plus 7. 1 and 7 is 8, 3 and 5 is 8, 8 and 16. Okay, even I can do that. I believe that's correct. Okay. Let's go back and have a look at that definition again. Do we have... This is my main program. This is the marker that will almost certainly wind up all over my shirt because I'm clumsy. Okay? That's my main program. Okay? It has a variable in it called values. I hope I'm pointing at the variable values. Okay? I call the function total. What happens is I grab another cup. Sum, thank you. I'm going to keep making that mistake, aren't I? I call the function sum, so I grab another cup. All of the variables inside the definition of my function are going to be written down on this cup. One of them is numbers, and the other one is total, and the third one is n. Okay? You can see them on this cup. Okay? Very carefully put the pen away. You may not feel a sense of victory, but I do because the shirt is still white. Okay. This is my main program. When I call a function, I grab another cup. It's got its own variables, and I stack them up like that. I can only see the stuff that's in the top cup, the stuff that's at the top of the stack. I cannot get at this stuff anymore. Right? So right now, inside the call to the function, I've got numbers, total, and n. I cannot, inside here, go and see that list of values. Why am I able to add those numbers up? Well, numbers and values are the same thing. I've given it a local name inside this function, numbers. All right? Just as I've got a local name total and a local name n. They are inside the function. They're in this cup. Okay? It happens that numbers has 1357 in it because that's what I passed in from here. Right? Values here was 1357. When I said total of values, those numbers got matched up with that. So numbers is now 1357. Total is 0. Do the loop. As soon as I return from the function, I throw that cup away, and now I've got this one again. Those variables disappeared. Once the function finishes, there is no such thing as total anymore. There is no such thing as n. There is no variable called numbers anymore. Values is still 1357. I haven't disturbed that because I've got a copy of it in here. Work on that. Then I throw this away. These are the only variables that I've got left. If I call total again, I'll grab another cup, create fresh copies of the variables, numbers, total, and n, and start all over again. Some people think, and it's a reasonable thing to think, that these variables remember their values between successive calls. If I call the function and give it values, okay, return to the main program, call the function again, it's reasonable to think that the old values for total and n are still going to be there. No, they're not. Okay. As soon as the function call completes, we throw the cup away, and that information is lost. Okay. It's called a stack frame. This is the stack. Because if this function was calling another, I'd have a third cup, a fourth cup, a fifth cup. I'd stack them all up. And at any point in time, I'm only working in the variables that are on the top cup. The other ones are all hidden. I can only get at the ones that are in the top cup. Why do we do this? Well, programs are written this way, and programming languages enforce this, because I might have 2 functions, or 3, or 50, that define variables called total. If they're all talking about the same variable, I'm never going to figure out what my program is doing. So I want to make sure that when I call you, any variables you create belong to you, and nobody else can mess with them. And, conversely, that you can't get at anybody else's variables and mess with them. Because if I call you, and then you call her, and she calls her, and she calls him, and you're all messing around with each other's variables, how am I ever going to debug that? So instead, we hide the information. This is the blob. This is all you get. Okay? It does its work, and then it returns. You can pass values in. You can return results. So there's only one input and one output. Right? And it doesn't have side effects. Right? You don't have that horrible feeling you often have during house renovations, where you go to the kitchen and you say, right, water pressure problem, I'm just going to replace this piece of pipe. And you replace the piece of pipe in the kitchen, and you get it welded back in, and you pay the plumber, and the plumber goes away. And 2 hours later, you have water spraying out from the upstairs bathroom taps, and you don't know why. You don't know what's behind the wall. You just know there was an unexpected long-range interaction, and it's going to be very, very expensive on a Saturday afternoon to get the plumber back. Thank you very much. Past life experience intruding into present-day reality. So, you don't want that happening. You want your programs to be modular. This is a module of code. This is a lump of code. You can see what's coming in. You can see what's coming out. It is self-contained, and that's how you want it. Now, I told you that you couldn't actually see any of the other variables. I lied. If you want to in Python, you can get there. You could, inside this function, reach back up here to values. You could reach down in the stack to other cups. Okay? If you do this, I will be sad or angry or both. I'm a parent. I can do both at once. Okay? It makes the code much more fragile, much more likely to break, and it also makes it harder to reuse. If this is a lump of code, and there's stuff coming in and stuff coming out, and it's self-contained, you have some chance of figuring it out. If in here you say something like return total over normalization factor, and you look at it and you say, but there's nothing in here called normalization factor. And now you have to hunt around through the rest of the program to find that variable, and then hope that you found the right one, because maybe there are 3 different places where normalization factor is defined, and you don't know which one this piece of code is talking about. Your problem just went from this big to this big, and is still growing. The rule you always want to follow is values in, value out, no side effects. It doesn't rely on anything outside, and it doesn't modify anything outside. There are times when you break this rule. We will break this rule this week. Okay? But that's your starting point. If you break the rule, you better do so for a good